everyone. My name is Alon. I'm the CEO of SSV Labs. We are building Compose, which is an interop layer that brings synchronous composability to Ethereum. We've been also the team behind SSV Network, which I'm sure a lot of you know. SSV Network is the largest distributed validators protocol on Ethereum today, with roughly 5 million ETH staked. The second largest protocol on Ethereum in staking, with 14% of the total ETH staked in Ethereum, and with amazing partners building on top of us. And of course, Compose is actually building on top of the SSV validator set. And we'll see in a second how that works. When we, as Ethereum, started to talk about scalability, actually the original plan was to do Ethereum sharding, which is basically kind of split up the state of Ethereum into different kind of independent chains, if you will, and each chain has its own way of building their blocks, and somehow magically Ethereum will combine all of those chains, including some kind of interop or composability between those chains, and that will be the way to scale Ethereum. That's been kind of the dream vision behind Ethereum for quite a long time. And a few years ago, Vitalik and others in the EF kind of realized that doing sharding is very, very difficult. And so we pivoted towards a roll-up centric roadmap, which has some of the characteristics of shards. For example, they do settle on Ethereum, they do derive their security from Ethereum itself, but without any interop, or at least built-in interop between them. And of course, that created what we know today is kind of the roll-up centric roadmap, with many, many different roll-ups. I think today we have roughly 100 plus roll-ups running on Ethereum, and a bunch of them continuing to kind of join, and even some L1s are turning into roll-ups. But it also created fragmentation, right? Each roll-up, even though they settle together on Ethereum, still has its own state, and by many consider its own chain. And so dApps are not necessarily can call one another, contracts cannot call one another, liquidity is fragmented, and of course users are kind of coexisting on a bunch of different roll-ups at the same time. So it feels like Ethereum is not really one piece, right? It's kind of Ethereum in the middle and a bunch of economic islands around it, which I think kind of goes against what Ethereum is trying to achieve. But also we should look back in history with kind of looking at similar architectures like Cosmos, for example, and see that as a warning of what could happen if we don't really focus on the way that roll-ups in between themselves can actually interact. There are a few kind of quote-unquote bridges that were built along the way, but none of them are really doing the job of kind of composing together or making Ethereum this one big continent, if you will, together. One of those solutions is asynchronous message passing, which is essentially a nice way to say that you can pass messages between roll-ups through some kind of a trusted committee or oracle, but those messages, you don't have any guarantees on when they will be delivered, or if they will even be delivered. And if you want to compose a bunch of different things in one transaction or one go, you need to do it block by block, transaction after transaction. This is the kind of the asynchronous property of those messages. And also, most importantly, the latency between them is quite big. And so in terms of composability, it's not really a great tool to use. Another type of solution are intents. Intents actually takes a completely different approach, where the user describes what they want to get, and then off-chain intermediaries kind of try to figure out how to execute. So, for example, swaps and cross-chain bridging works similarly. So I'm, as a user on chain A, I want to get the same token or a different token on a chain B. I say how much of those tokens do I want to move, and what is the fee I'm willing to pay. The problem is that it's heavily based on intermediaries and liquidity, meaning that ultimately the types of use cases are limited, because if you make very complicated use cases, you'll need equally complicated solvers or off-chain intermediaries. And also it's very liquidity heavy, meaning that somebody needs to front liquidity in order for intents to work. The result of that is that, one, not all rollups can actually tap into that, and two, ultimately it's very limited use cases. and very limited amount of tokens with high liquidity. Again, because it's based on liquidity. Another point is that we're forgetting that actually when you want to bridge a token between rollups, the end goal is not to bridge the token. The end goal is to do something on the other chain. And to that end, there is no composability with intents, because intents in of themselves are asynchronous, meaning you request it once, and at some point in the future, somebody will complete that transaction. The UX is pretty good, like it's very fast, but it's still asynchronous, meaning composability is always a 2, 3, or 4-step process, which again kind of goes against what we're trying to do with composability and interop in general in Ethereum. What we want to present is something called synchronous composability. Synchronous composability is this idea that there are 3 main properties we really want to have when you're talking about cross-chain transactions. The first one is encapsulation or composability. It's simply the idea that you can compose a bunch of interactions within one transaction. So imagine that you want to transfer your assets to another chain and then do something with a contract and then return and go to another chain. It seems obvious that on Ethereum you can do that, right? Of course, there are no chains on Ethereum, but if you want to compose a bunch of contract interactions on Ethereum, it's trivial. And so that's the composability or encapsulation part. The second part is atomicity, meaning that all of those interactions happen together or don't happen at all. It seems minor, but it's actually one of the most fundamental properties in financial transactions. So imagine that you want to transfer or swap a token. You want to guarantee that your token that you're selling is going out and something goes in, the token you're swapping to, but those are code-dependent, right? You cannot have a situation where you're just sending your tokens and not getting anything back, and obviously vice versa, which is kind of a double spend problem. The third property is synchronicity, meaning that everything I've talked about happens instantly in one transaction, not across multiple blocks, which can cause state changes and rollbacks and stuff like that. And so those 3 properties are something we're all used to on Ethereum, but when we port them to cross rollup transactions, it's called synchronous composability. We're all used to having that on Ethereum, but now we want to bring that to cross rollup interactions. And if I need to kind of chart how we compare all of those types of solutions, then you currently either have very generic but very slow approaches to interop, like asynchronous message passing, or you have pretty fast but very specific type of transactions which are intense. With synchronous composability, we try to do both. Super fast, but also super expressive and generic, so you can basically do any type of interaction you are used to do on Ethereum between rollups. And that's what Compose is. Compose aims to consolidate liquidity, dApps, and users. It aims to create a user experience which is just like Ethereum. It's not between rollups, it's just Ethereum, right? And it's instant, meaning that whenever the transaction hits the block, that's it, that's where it's executed. There's no multi-block type of waiting and latency and stuff like that. And there's ZK guarantees for atomicity, meaning everything you want to do happens or doesn't happen. And there's no kind of this locking and unlocking or waiting for your assets to unfreeze if something went bad. And so that's what kind of Compose is aiming to do. And the tech it's built on top of is called shared publishing. The shared publishing is actually built on top of SSV validators, meaning that validators are actually the ones running this piece of software. The idea there is to have it as a credibly neutral layer that many rollups can integrate to. It doesn't have to trust anyone, it's just Ethereum validators. And that shared publishing is the one that guarantees synchronicity and atomicity for those transactions. What happens is between rollups, the sequencers of those rollups can actually form the cross-chain transaction. Each rollup has its own independent sequencer, and they just produce blocks and ZK proofs for those blocks. Those blocks and ZK proofs are then aggregated using the shared publishing and then settled on Ethereum, obviously guaranteed by ZK proofs. It all starts with the concept of a mailbox. So each rollup has its own mailbox with in and out boxes. And when they want to move messages, or in other words, call other contracts on other chains, they simply move messages in between. Inbox is the messages you on rollup A receive, and the outbox is obviously the messages you want to send elsewhere. And the cool part about it is a very simple construct, but it's a very powerful one because it's kind of the basis on which we can guarantee the execution and atomicity and validity of that execution between rollups. The way it works is through simulations. When you want to do a cross-chain transaction, the sequencers simulate between them the actual transaction. It happens very, very fast. We're using a very lightweight consensus protocol, which is kind of a very simplified version of the BFT protocols we're all used to from staking, for example, on Ethereum and other protocols. By the way, we're using a BFT protocol in SSV. This is a much more lighter weight version of that, and it's super fast. And they simulate between one another the transactions, the cross-chain transaction, and they pre-populate messages in the inbox respectively. And they come to a decision if they want to proceed to execution or not. And if they do want to go to execution, each one of them executes. Now what happens in reality is, because we have the simulation part, each rollup, when it executes, it's executing as if it's a synchronous action, meaning it can do one after the other because we already did the simulation part. They do the execution, they produce a block, produce a ZK proof, and send it over to the shared publishing layer, which are the SSV validators. The validators are aggregating those ZK proofs together and also add into a super block validity conditions for the mailboxes, meaning that the inbox of one rollup, or the root of the inbox of one rollup, has to be equal to the root of the outbox of another. This is how we check for validity. And the ZK proofs are also guaranteeing the atomicity, because if anything goes wrong in it, they'll have to reorg and redo the transaction. And so there's no way that one side only executed versus another. I want to go back to this slide. What you'll notice is we have the opted-in rollups that are part of Compose, but we also have external rollups here, Base, Arbitrum, and other rollups as well. Because we have independent sequencers, we can actually create synchronous composable transactions between a Compose rollup and those rollups, meaning that Compose rollups can tap into the liquidity, users, and dApps of the bigger rollups, Base, Arbitrum, OP Stack, and OP Mainnet, and so on, in a seamless transaction. And that's a really, really powerful thing, because we can bootstrap from day one using the liquidity, dApps, and users of those bigger rollups, which is super important. And so this is kind of how the shared publishing works. But the cool part about it is synchronous composability opens up the door for much more use cases than we're used to in intense or asynchronous message passing. The first two ones, bridging and swaps, are done instantly, no latency, without any intermediaries. You can literally bridge a token or swap a token with no latency. The same way it feels and looks like on Ethereum, a single transaction, and it's done. And we actually just now made it so that we can swap a token on another chain and return the asset we swapped into the original chain in one transaction. That's it. It's literally as fast as it can be included in a block. And so that's a very powerful primitive. But synchronous composability goes far beyond swaps and bridging. It goes into things like cross-chain flash loans. Or you can have cross-chain transactions which involve more than 2 rollups, 3, 4, 5 different rollups. You can have multi-rollup DEX routing, which is incredible. Find the best price out of many rollups, not just one. You can even do NFT bridging. The implications on developers is immense, because it enables you to do arbitrary read and writes to any rollup in any contract. And also, it introduces a concept called a singleton dApp deployment, meaning that because you have synchronous composability, and because there is no friction between rollups anymore, as a developer, you can simply deploy your contract once. You don't need to deploy it on every rollup. And so you consolidate liquidity and users and remove a lot of the overhead of deploying on many, many different rollups. And that's a very powerful shift in the way we think about interop and the way we think about the rollup-centric roadmap. It also has the side effect of actually enabling the smaller rollups to bootstrap using the bigger ones. And so in terms of competitiveness, it really, really pushes the boundaries of what's possible. And so all of that is introduced with synchronous composability. I think this is the way Ethereum should be talking about interop and talking about its roadmap instead of trying to patch things with temporary solutions, we need to look at the problem and understand that the UX is the most important thing. What can we enable from a UX point of view that enables Ethereum to just feel like Ethereum, not be on Ethereum and feel like Base or feel like Unichain and feel like any other thing. And I think that's critical for Ethereum and Ethereum's future. In terms of the roadmap, we've been working on this behind the scenes for a few months, and we're just ready to release the first testnet for Compose. Throughout and until the end of year, we'll actually be integrating for the first time Base into Compose. So you'll be able to do on testnet transactions with Base, the Base testnet. And then throughout 2026, we'll be starting to roll out Compose in various pieces and so on. And so if you want to learn more, we actually have a cool Compose lounge today. Scan the QR code if you want to join and talk more about interop and how Compose can really help Ethereum. Thank you.
Thank you very much, Alon. We do have about 5 minutes for questions before break. Are there any questions from the audience here? Oh, perfect. I can have you stand up and walk this way.
Hi there, Alon. If that works, it's kind of the holy grail, right? Right now, SSV has 14% of staked ETH. What percentage of staked ETH needs to be supporting this shared publisher before critical mass is hit for the Compose network?
So it depends on what exactly in the life cycle of Compose you're talking about. I've just talked about L2 to L2 composability. But there's another big elephant in the room, which is L1 to L2 composability. That requires real-time ZK proofs. And to that end, you actually need much more validators, potentially almost all of the validators on Ethereum, because then you can have real-time proving and real-time execution between L1 and L2. That's a bit into the future. For currently to do L2 to L2 composability, you don't need any more validators. I think it's decentralized enough as a layer for other rollups to trust and be credibly neutral with to have this amount of validators. We have enough validators with enough entities and enough different actors within it to, I think, build a really solid base for it. If we're looking into the future and want to have L1 to L2 real-time composability, then it's going to take a bit more, but it also depends on real-time ZK proofs.
How does Compose fit into the EF's coordination efforts around chain abstraction?
So chain abstraction, I think, is more on the wallet side, at least from what I know, and I think it goes very, very, very well. I haven't touched upon it yet here, but we're making a heavy use of account abstraction and user ops to achieve the best UX we can. We actually heard a conversation between the major L2s yesterday at the main event, where they talked about adopting, specifically Base, adopting account abstraction and 7702 natively in their wallets. And so all of those things are very much things that we need as well. And so we are making use of all of those bits and bytes that the EF and others are building. I think account abstraction can really work well in this. By the way, I don't know if you saw the announcement by the account abstraction team with the Ethereum interop layer. Today or tomorrow they have their event, but they're making the same type of use cases with account abstraction and user ops as we do, meaning that you sign once and you execute on multiple chains. And so in various ways we are using all of those kind of techniques and bits and bytes.
Excellent.
I have a follow-up question to the amount of validators. So if I understand this right, the idea is to start with the SSV network, but not stop there. So the way you would get L1 to L2 eventually is by opening this up to really any Ethereum validator.
Yeah, I think ultimately if Compose is going to be the kind of the gold standard for interop, yeah, it needs to be open up for everything. When and where, it's kind of depends on where we get to. We'll start with the SSV validators, obviously, because it's easy, and of course we're working in tight collaboration. But yeah, ultimately I think down the road, yeah, we'll potentially open it up to everyone.
Perfect. Thank you thank you very much, Alan. And you'll be around a little bit during break. We have a break for the next 15 minutes, so we're back here at 15 minutes.
Thank you, everyone.